Assalamualaikum and good day everyone. We are from group 2 and today we are going to present our project from what we learned about SIMUL8 in class. The title of our project is Simulation of Customer Flow in a Self-Service Laundry. The lecturer that guided us to complete and finish this project is Dr. Zaitul Marlizawati. Our lecturer for subject SSCM2853, Inventory Control and Queuing Theory. Before we start, I would like to introduce myself first. My name is Adriana Fujin and these are my group mates, Eris Kamela, Siti Sharafana, and Siti Nur Azul. To begin with, let us start from executive summary. Actually, what is the purpose of doing this study? Of course, we know that the main purpose is to evaluate the proposed self-service laundry system. Other than that, we want to analyze the customer flows and service processes to ensure the system is running smoothly. Moreover, we want to assess resource utilization efficiency, identify potential operational issue in the system and improve for overall system performances. Next, let's identify what is method that we use to do this project. We use SIMUL8 discrete event simulation software to perform our proposed scenario. We create a simulation model of customer arrivals and service processes by using this software. Also, the queue and resources allocation analysis can be determined by using SIMUL8. This performance evaluation was run by using key metrics. Next, I will pass to my friends, Aris.
Thank you, Adriana. So, good day, everyone. I'm Aris, and I will now continue with the findings of our simulation study. Based on the simulation results, we found that the current laundry system is not well balanced and cannot meet customer demand effectively. The washing stage is the main bottleneck because customers have to wait for an available washing machine, resulting in long queues and delays throughout the system. The drying stage also contributes to waiting time while the unloading and payment processes operate smoothly. Overall, these delays increase the total service time and may reduce customer satisfaction. To improve the system, we recommend adding 2 more dryers and increase the total number from 2 to 4. This improvement would help balance the flow between the washing and drying stages, reduce waiting time, and improve the overall efficiency of the laundries. In addition, maintaining a first-come, first-served or FCFS queue system and encouraging customers with smaller loads to use shorter drying cycles can further reduce congestion. This improvement will provide a smoother operation and a better experience for customers. Next, I will continue with the introduction. Self-service laundries have become increasingly popular because they provide a convenient, affordable, and accessible way for people to wash and dry their clothes. Customers can complete the entire laundry process by themselves without assistance from employees. However, customer arrivals vary throughout the day, especially during peak hours, which may result in long queue and waiting times if the available machines are insufficient. Therefore, it is important to evaluate the system to ensure that it can provide efficient service while making good use of this resource. Next, for this study, we considered a self-service laundry equipped with 4 washing machines and 2 dryers. When customers arrive, they first make their payment before waiting for an available washing machines. If any washing machines are occupied, they join a queue until one becomes available. Each washing cycle takes approximately 35 minutes. After washing is completed, customers move to the drying stage, where each drying cycle takes about 25 minutes. If all dryers are in use, customers must wait until a dryer becomes available. After drying, they unload their laundry and leave the laundry. This scenario was modeled in SIMUL8 to evaluate the efficiency of the current system and identify any operational bottleneck. The objective of this study are, first, to develop a discrete event simulation model of a self-service laundry using SIMUL8. Second, to evaluate the operational performance of the laundries based on selected performance measures. Third, to identify bottlenecks and operational issues within the system. And finally, to propose improvement strategies to enhance system efficiency and improve customer service. That concludes my presentation. So thank you.
Hi, I'm Siti Sharfana. I will present the methodology and result for our laundry simulation project. As shown on this slide, our model is built on real-world data and clear system assumption. To establish a baseline, we collected field data tracking 10 customer arrivals, capturing their exact arrival, washing, and drying times. Our operational assumptions are listed on the right. The laundry has a finite queue capacity due to space limits, and all lines operate on a first-come, first-served. If a queue is full, arriving customer leave the system. We factor in 3-minute loading or unloading time, fixed mission cycles, and assume 100% equipment reliability over a 24-hour simulation run, which equal 1,440 minutes. Next, this slide illustrates our SIMUL8 model logic and component parameters. The flowchart on the left maps the sequential customer journey, arrival, payment kiosk, washer queue, washing, washer unloading, dryer queue, drying, dryer unloading, and final system departure. The parameter table on the right shows our SIMUL8 settings. Customer arrival follow an exponential distribution, which is 4 minutes. Meanwhile, the kiosk, washing, drying, and unloading steps are set to fixed distributions. Keeping this service time constant allows us to isolate exactly how arrival fluctuations create system delays. Finally, this slide presents our simulation result. The data highlight two major bottlenecks. First, the queue for washer averaged 3.9 customers, causing a long wait time of 42.91 minutes. Second, the queue for unloading washer averaged a 36.73 minute delay just to empty the machine. Because of these delays, the total system time WS reached a high average of 242.14 minutes. In conclusion, washer availability and unloading delay are heavily limiting performance. To fix this, we recommend adding more drying units to speed up machine turnover and reduce system wait times. That's all from me. Thank you.
Based on the SIMUL8 results, the analysis found that there are severe business loss where laundrette failed to capture the measure of market's demands, losing 179 customers from 329 arrivals. Other than that, extreme service delay were few customers that successfully entered and completed the process in the system, experiencing highly inconsistent service times. Lastly, low system throughput. Only 110 customers able to complete the entire washing and drying cycle within the simulated period. From the SIMUL8 results, we also know that the core bottleneck is the drying machine. There are 4 washers but only 2 dryers creates a severe capacity mismatch. Since the 2 dryers already full, the completed wet laundry becomes trapped inside the washer queue, causing unloading delay of 38.73 minutes. This leads to cascading congestion, where the SS blockage ripples backward and forcing new customers to wait an average of 42.91 minutes just to use washing machine.
Assalamualaikum and hi, my name is Siti Nur Azwa and now we will be moving on to our improvement of study. This slide shows how we set up our simulation configurations in SIMUL8 to test our solution. So firstly, we look at the baseline model. This model was developed to evaluate the current laundry operations over a simulated 1-day period, which is around 1,440 minutes. During this baseline run, we found an observed constraint, which is we noticed that the limited dryer capacity of only 2 units forced an upstream backup, which caused clothes to get stuck at the washing stage. To try and fix this issue, we created the improvement model, which is for this setup, the dryer capacity was modified from 2 to 4 units inside the SIMUL8 software. And lastly, to make sure we had a fair and balanced comparison, we kept our control variable identical. This means that the customer arrival rates and the washing process distributions were exactly the same in both simulation runs. Now, let us look at the comparison of our simulation results between the baseline model and the improved model. Firstly, for both configurations, the total customer arrival was kept constant at 329 to ensure a fair test. When we look at the customer count, the improved model shows positive changes. The number of lost customers dropped from 197 down to 159. At the same time, the number of completed customers increased from 110 to 156. The most notable improvements are seen in the waiting times, which is the average washer queue wait time was reduced significantly, dropping from 42 minutes down to 3 minutes. And next, the average washer unloading delay went from 38 minutes all the way down to 0 minutes. This indicates that the clothes no longer get stuck inside the washing machines. As a result of these improvements, the average total time in the system was cut by more than half, which is decreasing from 242 minutes to 130 minutes. So next, we will discuss the operational insights and analysis behind these numbers. Now we move on to our operational insights and analysis on this slide. Firstly, for the bottleneck reduction, the model shows that adding 2 more dryers can help reduce the 38.73 minutes waiting time to take clothes out of the washer. And second, for the system flow, fixing the long lines at the dryers appears to help lower the washer waiting line to about 3.74 minutes. Thirdly, regarding the customer count changes, a better workflow helps the shop serve more customers and helps to stop people from walking away during this run. And finally, for the evaluation, the simulation data suggests that buying 2 more dryers is a reasonable choice to help the shop work better under these conditions. And lastly, we will move on to the final conclusion. To wrap up our presentation, let us look at the final conclusion. Firstly, our project goal was to use SIMUL8 to see if the laundry shop can manage customer demand and reduce waiting times. Secondly, for the main problem, the data suggests that the old system was not efficient because having only 2 dryers for 4 washers created a long waiting line. Thirdly, for the solution, the model shows that adding 2 more dryers helps clear the waiting line, where it reduces the total system time from 242 minutes to 130 minutes, and it also helps to serve more customers. Finally, as a final lesson, this project indicates that SIMUL8 serves as a useful tool to find problems and to test changes safely. The data suggests that expanding the dryer count has the potential to help the laundry shop work better under these conditions. Thank you.